Welcome to today's daily video lesson. Today's topic is properties of fundamental functions. As with all daily video lessons, feel free to pause the video before seeing the solution. In this problem, we are given a function. We are told that 2 is a zero of our function, and then we are asked to find k. What does this sentence mean? Well, if 2 is a zero, that means plugging in x equals 2 will result in the function being equal to 0. We can plug these in. If p of 2 is 0 and x is 2, we have 2 squared minus 11 times 2 plus k. This simplifies to be 4 minus 22 plus k, so k is 18. This is an example of an exponential function. We want to understand how exponential functions are built. The number that is the base of the power, or the exponent, is going to indicate by how much you multiply the original amount. The fraction is going to indicate how long it takes for such a multiplication to occur. Thus, we see that the answer is going to be A. The dish we know has to triple because the base number is a 3. That means we would multiply whatever existing amount is by 3, which is tripling. We also know it has to occur every 2 days, because in the fraction it is t over 2. This is a more analytical function problem. We're given two definitions, a definition for f and a definition of g, where g relates to f. We're asked to find the value of g of 3. When given these kinds of problems, simply plug in and solve. G of 3 from the definition of g is going to be f of 3 plus 5. And f of 3 from the definition given is 3 times 3 plus 5, and then plus 5. We see that this is going to be 3 times 8, which is 24, plus 5. So the correct answer will be option D. In this question, we want to be familiar with converting a function and recognizing its HK form. In general, the HK form is y is equal to f of x minus h plus k. Options B, C, and D all fail to have this particular format because the function is a quadratic. Thus, we see that option A is correct, as it has x minus h plus k. In this case, it would be plus minus 25 for k, but you are allowed to add negative numbers. If you did want to verify that this indeed simplifies and is equivalent to the original parabola, expand the square and get x squared minus 6x plus 9 minus 25, and the 9 minus 25 becomes minus 16. In this problem, we are interested in understanding the difference and the similarities between x-intercepts, zeros, and the roots of polynomials. We are given a polynomial. We're told that these constants, h and k, are positive. On top of that, h and k are told to be not the same number. We want to know the number of distinct x-intercepts the graph has. Don't forget that an x-intercept is simply a 0. That is, we want to find the zeros of this polynomial. We see that if x is equal to h, then we will have a 0 because of the first term. We see that if x is equal to minus h, we will have a 0 for the second term. And if x is equal to minus k, we will have a 0 in this third term. Since we have been told that h is not the same number as k, we're guaranteed at least these 3 distinct zeros. Don't be thrown off by the square here.